Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Statistics series and concerns measurements of central tendency. This guide introduces two different measurements of central tendency, the mean and the median. It shows how to calculate them and gives guidance for using them appropriately. Introduction. In statistics, it is extremely useful to have a measure of the value of the middle of a data set. This can be thought of as a typical or average value, but is more correctly called the measurement of central tendency. The word average is ambiguous, as there are different ways of calculating and describing the centre of a data set. Measurements of central tendency are part of the group of fundamental descriptive statistics. Many descriptions of research, which include statistics, will be interpreted in terms of an average, and you should be comfortable making informed decisions regarding such statements. For example, the average yearly student debt for England is £4,729. This figure should not suggest to you that every student in England has debts of £4,729. One interpretation could be that if the total debts of students in England were evenly distributed between them, each would owe £4,729. Another would be that if all the student debts were written out in order from smallest to largest, then £4,729 would be directly in the middle. Measurements of central tendency are useful as they can summarise some aspects of information regarding a large amount of data into a single value. However, they should not be used as the only descriptive statistic for a data set, as they give no information about the variability of the data within a data set. Measurements of central tendency are combined with measurements of spread to give a better description of a data set. See study guides, measurements of spread 1 and 2. You may have an inherent understanding of what is meant by an average, but because there are different levels of data in statistics, see study guide levels of data, there are different ways of calculating the middle of a data set. Two measures of the middle of a data set are the mean and the median. The centre of certain data sets can be described by either of these, and each may be a different value. There are also data sets which can only be described by a specific measurement of central tendency. It is important that you understand which measurement is appropriate and which, if any, is best to describe the middle of your particular data set. The mode is usually mentioned alongside the mean and the median, but it is not strictly a measure of the centre of a data set, and so is discussed in the separate study guide, the mode. The mean. The mean of a data set is what most people quote when they give an average. The correct term for this measurement of central tendency is the arithmetic mean. However, it is so common that it is usually referred to simply as the mean. The mean is calculated by adding up all the values in a data set and then dividing by the number of pieces of data in that set. Mathematically, the calculation for the mean is described by the equation x bar equals the sum over x divided by n, where x bar, pronounced x bar, is the mathematical symbol for the mean. Here, each piece of data is described by x, and the Greek capital letter sigma, a very common symbol in statistics, tells you to add them all up. Finally, the number of pieces of data is given by n. Example: 6 students were asked about the amount of student loan they had taken out for a specific academic year. They said £3,400, £2,800, £4,500, £3,500, £3,750 and £4,625 respectively. What is the average loan for these students? To use the formula above, you need to know the x's, which are the individual amounts of student loans: £3,400, £2,800, £4,500, £3,500, £3,750, £4,625, and n, which is the number of students, n equals 6. You can now use the formula. the mean, x bar, equals the sum over x divided by n. Adding up the x's is 3,400 plus 2,800 plus 4,500 plus 3,500 plus 3,750 plus 4,625. N is 6. The sum is 22,575, which needs to be divided by 6, which gives 3,762.5. So the average mean loan is £3,762.50. The example illustrates that the calculation of the mean takes into account every value in a data set. This can be a disadvantage if your data are spread apart, as the mean begins to lose its effectiveness, as the mean is sensitive to individual data points which are very large or very small with respect to the rest of the data. These types of data are called outliers, and the mean can be distorted by them. Example: calculate the mean wages for staff working in offices A and B. Office A salaries, thousands of pounds. 15, 18, 17, 14, 16, 18, 15, 17, 12, 20. Office B salaries, thousands of pounds. 15, 18, 16, 14, 15, 16, 12, 17, 90, 95. Using the formula for the mean for Office A, indicated by a subscript A in the calculation, the mean of Office A equals the sum of the wages divided by n, which equals this, which gives 16.2. So the mean wage for Office A is £16,200. Similarly for Office B, the mean for Office B is the sum of the wages divided by n, which is this, which equals 30.8. So the mean wage for Office B is £30,800, even though most workers have a salary of around £16,000. These two results show that the mean wage is much higher in Office B. The mean of Office B is distorted by the two high wages, or outliers, of £90,000 and £95,000, and so it may not be the most suitable statistic to describe the centre of that data set. The middle of a data set with outliers is best described by the median, see following section. However, as the spread of salaries for the workers in Office A is much narrower, the mean is a good measure of the centre of this data set. The mean is also unsuitable for non-interval levels of data. It makes no sense to use the method above to try and calculate the mean of a nominal data set. Could you have a mean favourite fruit, for example? For ordinal data, you may think that the mean is suitable. Take questionnaires, which ask you to rate your happiness on a scale of 1 to 10, for example. But it is not. Even though you can add up all the scores and then divide by the total number of correspondents, each happiness score is subjective. A score of 8 does not necessarily mean twice as happy as a score of 4, and so the value of mean loses its effectiveness. The median. When a data set is arranged, i.e. sorted, in ascending or descending order, the middle value of that list is described as the median. To find the median, you must consider the number of pieces of your data set. If the number is odd, then the median is located at the exact centre of the list. If the number is even, then the median is the mean value of the two central values. As you ordered the data, the median is not adversely affected by outliers and is most suitable way of describing the centre for ordinal data. Example: 11 families were asked how many children they had. The replies were 3, 4, 2, 5, 0, 0, 1, 3, 1, 1 and 2. What is the median number of children per household? Firstly, arrange the numbers in order, and then pick the central value as you have an odd number of data. The central value in bold is the sixth value, as there are 5 values above and 5 values below. and so the median is 2. Example: 10 students take a test and the results are as follows: 18, 14, 7, 13, 12, 13, 12, 19, 10 and 11. What is the median score? Again, arrange the scores in order. Here you have an even number of results, so you must find the middle two data, which are the 6th and the 7th. Taking the mean of these two values, 12 plus 13 divided by 2 equals 12.5, and so a score of 12.5 is the median. The median is an excellent representation of central tendency when your data set contains outliers. If you look again at the salaries for Office A and for Office B, arranged in order, Office A is this, and Office B is this. The median for Office A is £16,500, which is the mean of £16,000 and £17,000. And for Office B is £16,000, which is the mean of £16,000 and £16,000. Remember that the mean for the Office A was £16,200 and the mean for Office B was £30,800. When you compare these, the mean and the median wages for Office A and for Office B, it becomes obvious just how much the outliers have affected the mean for Office B. Here it would be more sensible to report the median wage for Office B as the measure of central tendency. Further guidance and information. If you have any further questions about statistics or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.